Okay, so we're going to be factoring again today. And I'm just going to start with a factor tree, which is just something I came up with just like to organize your thoughts for factoring. So always step one is to see if you have a GCF, right? That's always your first step. And then whatever remains is what you're going to do next. So if you have like whatever remains in the parentheses, it might be a binomial or a trinomial. It could be different things too, but this is what we're dealing with at this point. There we go, class is almost full now. Okay. All right, if it's a binomial, we want to ask ourselves if it's a difference of squares. And remember that was a squared minus b squared factors into a plus b, a minus b. If it's not, then you're just done. If it's a trinomial, is it a factorable quadratic trinomial? We dealt with two types on Monday. We dealt with, because it's ax squared plus bx plus c, so we dealt with when a was 1 and when a wasn't 1. And we went through the box method a little bit, and that's what we'll mainly use today. So that's like our main thought process here. Okay, let's go through our first example. And then in a minute, I'm going to erase the factor tree that I just made there. Simon, was that you who just came in?
It was me.
All right, if you guys have the ability to have your webcam, just have it on. It's not like, I'm not trying to be weird. It's just what we were told at our meeting this morning. So if you have it, just to make sure you're following along. If you don't have one, that's totally fine. Just so I can kind of scroll through and see how we're doing. Okay, let's start with the first example. So all of these are just going to be factor it, that's all. So our first one's going to be 3x squared minus 48. So these are going to be a little more complex than the ones we did the other day, just because we're putting everything together. So our first step is GCF. We do see that we do have a GCF here. It's 3, right? A quick little thing to see if something's divisible by 3 is if you add 4 plus 8, you get 12, and 12 is divisible by 3. So 48 is divisible by 3, kind of like a cool trick you can do. So we can take out a 3 and go ahead and write what you have left. And you probably will use a calculator today just because I have some bigger numbers. So if you need to use a calculator, that is good. All right, so we're left with x squared minus 16. Okay, so we factored out our GCF, and then what remains, right? So what's in our parentheses is a binomial. It has 2 terms. So if something's a binomial, it has the potential to be a difference of squares. In this case, it is, right? Both are perfect squares here, and we're taking a difference. So we can factor that inside piece. The 3 stays. And factoring with a difference of squares, it's going to be x plus 4 and x minus 4. Again, what remains, right? Do we have anything that remains that can still be factored? No. And so this is our final factored answer. So that one wasn't too bad. That's why I wanted to start with it. All right, I will reference that tree that I'm erasing here because I only have so much room. All right, next one. 6x cubed plus 58x squared plus 80x. Okay, Jacob, I'm going to ask you our question here. I want you to find what our GCF is.
2x.
Awesome, 2x. So they're all even, so they're definitely divisible by 2, if not something greater, but they're not divisible by anything more than 2. Go ahead and write the 3 terms that remain in there. And Josiah, in just a minute, I'm going to have you tell us what goes in here, okay?
Yes, ma'am. Right now?
Yeah, whenever you're ready.
Everything that you, like, if you took 2 out, everything, then the rest of it, I guess.
Mm-hmm.
3x. I don't know, what does the exponent do again?
We want to get back to x cubed. So essentially we want to add, this is an exponent of 1 here. And so we want to get back to 3 through addition, because that's the properties of exponents. So like x times x to the what will get you back to x cubed?
X times x to the second.
Yeah. So when you multiply powers, right, x to the first times x to the second, you add your exponent, so it gets us back to x cubed.
Yes, ma'am.
Okay, how about our next term?
29x.
Great, and our last one?
40x. 40.
It's just going to be 40, since we already took the x out, right? So 2x times 40 will get us back to 80x here.
Yes,
Thank you. Okay, so let's see what remains, right? So what remains is our trinomial. So when we have a quadratic trinomial here, we determine if it's like the easy one or the difficult one, right? So our a value here in this trinomial is 3. So we need to use the box method in order to make this one work. Yes, these numbers are a little bit bigger, but we can still do it. So in order to factor this, or to just see if it's factorable, our first step is we want to multiply a times c. All right, a times c. So I'm going to try out the box method here to factor it. Remember, box method is for quadratic trinomials, which we have in here. And our first step is going to be 3 times 40. So that's 3 times 4 is 12. Put a 0 on it. Okay, so we need 2 numbers that are going to multiply to 120 that are going to add to 29. So if you have your calculator, use that to see if you can find 2 values. If you don't, use a different piece of technology, phone, computer, something like that. You should be able, if you're on your phone on Zoom and need to use your calculator, you should be able to still use your calculator. It's fine if you leave the view for a second. And once somebody has it, you can just let me know.
5 and 24.
Was that Sylvia?
Yeah, that was me.
Wow. I can just tell who it is by your voices. That's crazy. Okay.
Let's go.
All right, so 5 and 24, you're right. Awesome. How did you find that so quickly, bud? What'd you do?
I just did 20 or 120 divided by 5. I got 24 of that.
Okay, awesome.
I was just like trying out some numbers.
Did you start that way every time you did 120 divided by different numbers?
I started at 3. So I did 3, 4, and 5.
Cool. Okay, awesome. So yeah, if you just divide 120 by different values to see if it's divisible by those. So then he divided it by 5. It was 24. 5 and 24 multiply to 120 and definitely add to 29. So those are our winners. That means that this is factorable. Since we found those values, this is a factorable quadratic. So we can go right into the box method. And the box method is we'll set up that like window pane looking thing with 4 compartments. All right, someone else want to shout out, do you remember what goes in each one of these 4 compartments?
It would be 3x squared at the top.
Awesome.
And then it would be 24x. I did just to the right.
Uh-huh.
And then 5x and then 40.
Awesome. Okay, so our first term of our trinomial goes first, our last term goes last. We just broke apart 29x into these 2 spots here with the numbers that we found. So essentially we're taking this quadratic trinomial and we are visually representing it using a box, or it looks like a window pane to me. These could be in different spots, it's fine. Okay, next step is to just do our GCF going down the columns and then across the rows. So I'll do one of each. Everything's positive in this problem, so we don't have to worry about negative signs at all, which is kind of nice. So if I look at the first column here, 3 and 5 don't have a GCF other than 1, so I don't have to worry about that, but they have an X in common. So I'm gonna take an X out. Here, oh, I'm not gonna do that one. You guys are gonna do this one. Here, going across the row, 3 and 24 have a 3 in common, and they both have an X, so I take out a 3X. You guys do the other 2. And then Michael A, I'm gonna ask you for one of them, and we'll do Michael Y. I'll ask you for the other one. And whenever you found him, you can just say him.
The left side is 3x plus 5. Like, yeah.
Cool. And yell whenever you have this one up here.
Is it 4x?
Even bigger. Bigger number than 4 can fit into both.
8x?
Mm-hmm. Just 8. See why it's just 8?
Yeah.
Awesome. Okay. So if we write this as our final answer, right, this is one of the factors, this is the other one. We still have to remember this 2x was our GCF from the start, so it's in our final answer. It doesn't matter the order that you write these, although I'll probably write the larger x one first. So 3x plus 5, x plus 8. And a way to check, honestly, like when I was doing some of these, I would forget values too. Like it's easy to put 4 here because they're definitely, 4 is a common factor, but 8's the greatest common factor between the two. If you were to multiply it out, right, 5 times that 4 wouldn't get you back to 40. That's how you know it's definitely 8 to get back there. So here we go. Nice. All right, how we doing, guys?
Good.
Is it too early?
Kind of.
Okay. All right, let's try another one. 2x squared minus 20x plus 42. I want you guys to do the first step of your factor tree, which is GCF. And then, Jeb, I'll have you work through that first line with us, okay?
Okay.
Okay.
Do we have to like do what we did in the last problem, or do we just go straight to the box method? since there's only.
You always want to do GCF first. There is a GCF
All right.
here.
Okay.
Easy way to note that, little math tricks, they're all even. So if numbers are even, they're automatically divisible by 2.
2, yeah.
You walk us through it whenever you're ready, bud.
Okay. So the first one would be x squared. Then minus 10x. And plus 21.
Cool. Thank you. Okay. Now look what remains, right? What remains is a trinomial or a quadratic trinomial. And so to see if it's factorable, we take a times c. A is 1 here. So this is like an easier one. You don't necessarily need to use the box method, although you still could. But since a is 1, c is 21. So a times c is 21. So we want to see if there's two numbers that multiply to 21 that add up to negative 10. If anyone has those two numbers, go ahead and just shout them out.
Negative 7 and
3, 7, negative 7.
Cool, that's what I heard. Great.
Curry.
So the good thing here is you can practice box method if you want. If you want to go through box method every time you have a quadratic trinomial, that's fine. Personally, I don't think that you need to waste the time doing that because a is 1. It's just x squared. You can just go right into factoring it. These two numbers are just the numbers that you're going to have in your factors at the end, in your parentheses. So again, box method would give you these two, but you can just write them out. And that's because there's no fuss about numbers being in front of x here. We don't need to get a number other than 1 here. So you do not need to use the box method, although it would still provide you those answers. But that's an easier one, so don't waste your time.
Do you not need to use the box because there's just a 1 for the x squared? All right.
Exactly. Sorry, I just erased it, but that's why. It would still work though. Okay. All right, let's do another one. 4x squared plus 8x minus 21. All right, I want you guys to see if there's a GCF, always your first step. Okay, what do we think?
No.
No, right? The only possibilities, like numbers that fit into 4 would be like 2 and 4, and 21's not divisible by those. So there's no GCF. Okay. So we have a quadratic trinomial. Let's see if it's factorable. 4 times negative 21, let's see, 4 times 20 is 80, and then add on 4 1, so negative 84. And then are there two numbers that multiply to that add up to our B, our 8? There are, so I want you guys to find them. And since they need to multiply to a negative, right? One needs to be positive, one needs to be negative. The like bigger number needs to be positive 1.
I got 14 and negative 6.
Cool. Nice. Okay. So those are our two numbers, so it definitely is factorable. So I want you guys to set up the box method. Since A here is 4 and not 1, it's best to utilize this method. Okay, I've worked through it on the screen. Hopefully that was enough time to work through it. And again, mine might look like a different order than yours, but regardless of where you have the 4x squared and the 14x together, you can definitely take out a 2x. And wherever you have the 4x squared and the minus 6x together, you can take out 2x also. When you have the 14x and the minus 21, you can take out a 7, right? But since the first term in that column here, or in your row, however you wrote it, is positive, you take out a positive 7. The reason I took out a negative 3 here was because the first term in this row here was negative. And then these work. They definitely multiply to our original expression. And again, if you're unsure if it does, multiply it out, FOIL it out, and see that you get that 4x squared, negative 6x, positive 14x, right? These two values, we found how it's broken down. And then minus 21. So essentially we're just like foiling in reverse. That's what this method does. This found like the O and I terms here. So it's kind of cool. All right, I have 3 more. That's it. I'm gonna have you guys try. What's up?
Is there gonna be a quiz on Friday?
No, so I'm going to email it. Once we're done with class today, I'm going to email out a PDF that is your assignment. I guess I could just put it on Blackboard, but I still am not totally trustworthy of it. So I'm just going to email it to you. It'll be due Friday by 3:15 p.m.
Is Blackboard working now?
Yes. So
is,
yeah, please, I have the Dropbox open. The assignment should be open now for you guys to see. It's called homework due 4-3. But I made the homework when it still wasn't working. So on it, it says to email it to me. Don't, just upload it to Blackboard. But just our luck, it'll crash again. I don't know. We'll see. Okay, I want you guys to try this one. Go through your steps. And then let's see, Christian, I haven't heard from you yet. We'll all ask you something about this one, okay? All right, thumbs up, nice. So whenever you're ready to walk us through it, Christian, go ahead and you can start.
To be honest, I don't really know how to do this one.
Okay. What's our first step we want to do when factoring?
Check for a GCF.
Okay. Is there one?
No.
No. Okay, so what's our next step?
Put it in the box.
Box is only for quadratic trinomials, right? That's box method.
So
is this a trinomial?
no. Wait.
No, right? It's a binomial. So a binomial has the potential to be a difference of squares. Is this a difference of squares?
Oh, no.
Who can help him out?
Yes.
It is.
Okay. It is, right? Is 4 a perfect square?
Yes.
Yes. And is p to the 8th a perfect square? Can we take something, multiply it by itself to get p to the 8th?
Yes.
Yes.
Yeah. Which is what?
P4.
4.
Yeah, p to the 4.
2p4.
Right. So this is a difference of squares. So I want you to use the difference of squares, which is right here, to help us out. So how is this going to factor since it's a difference of squares?
Ah. So you're going to be 4 plus 25 and then 4 minus 25?
Okay, you need a variable in there.
Hold on. Sorry. Say it again, please.
And it's not going to be 4. So the reason that it's a difference of squares, so if you look here, a squared minus b squared, right? That's how it starts. But then it breaks down into the square root, a and b, a and b.
Mm-hmm.
So you have to find the square root of each term.
P to the 4th.
So it's
No, 2p to the 4th.
Okay. And then Christian, you tell me what's the square root of this term?
-5.
Okay, so just 5, right? Just 5, because the minus is built into the formula.
Okay.
Okay, so it's 2p to the 4th, 2p to the 4th, because that's the square root of this term. If we multiply it by itself, it gets us back here. And then the square root of our last, 25, is 5. And if we were to multiply those by each other, we get minus 25. So if you FOIL this out, if you multiply this out to check, we'll have 2p to the 4th times itself, which is 4p to the 8th. Then we'll multiply 2p to the 4th times minus 5, which is minus 10p to the 4th. Then we multiply here. That's a positive 10p to the 4th, and this is a minus 25. The O and the I terms cancel because they're the same, but just one was plus and one was minus. So we were left with our original, which is why that shortcut called difference of squares works. Okay, so this is our final answer up here. 2p to the 4th plus 5, 2p to the 4th minus 5. All right, let's do another one. Okay, 9p squared plus 73p plus 70. Okay, I want you guys to start this one. All right, so there's no GCF here. The only options would be things that go into the smallest number, like 3 and 9. 3 does not go into 73. 7 plus 3 is 10, and that's not divisible by 3. So it's a shortcut for divisibility by 3. 73 is also not divisible by 9. So there's no GCF. It is a trinomial. So we see if it's factorable by multiplying a times c and getting 630. So we want two numbers that multiply to 630 that add to 73. Has anybody gotten there yet?
Yeah, I'm trying to figure out the number right now.
Okay. It is a large number. However, when something ends in a 0, think about what that means. That's my hint for you.
Okay.
Are we gonna have big ones like these on like quizzes and tests?
On your assignment this week, yeah. It's only 6 problems, but they're a little more difficult since it's your only assignment for the week.
Okay, thank you.
And you'll have today, tomorrow, and Friday. Also,
Right.
just so you guys know, I know there's a lot of change this week, but your teachers all have office hours from 2 to 2:30, Monday through Thursday. So if you need to pop in, it's just the same Zoom link. And then on Friday, they're like how they were previously, like math and English is 9 to 9:50 on Friday. If you need to ask questions before this is due, you'll have 3 different office hour opportunities.
The numbers are 10 and 63.
Nice.
So we don't have any homework. Not homework. We don't have any class on Fridays.
Yeah.
Right.
Thanks, Alexa.
So Fridays, yeah. But Friday's technically still like a school day, so I can still make stuff due.
Hurry up.
But you don't have to log in. So I'll make
Um,
things due on Friday, but you can turn them in early if you don't want to worry about school on
Boys,
Fridays.
where's Corbett at?
Sounds good.
Toland, you're in mix.
Dude.
Sometimes I wonder if you guys speak English to each other. Sounds like a different language.
It's the lingo, Mr. Maj.
Yeah, I'm not hip with the kids. Okay, so we have that, and then the order doesn't matter that you write these. This one took me a second to figure out too. Like, I did not think of these numbers right away, but just like little math tricks that you'll see, like it ends in a 0, so it's definitely divisible by 10. So that's like a little thing you can do. All right, Simon, I haven't really picked on you today, so I'm gonna ask you to help us out with the box method when you're ready.
Okay.
Okay.
Did you set it up the same way I did, or do you want me to switch around 63 and 10?
Can you switch around 63?
Oh my god.
Sure. It's all good. Whenever you're ready, bud.
Let's see. Yeah, I don't understand this.
Okay. So what we want to do is take the GCF going down each column first, and we write those above. So our first column has 9p squared and 10p. What's the GCF of these two terms?
Of 9 and where?
Of 9p squared and 10p going down the first column.
Would we what is it? Would it just be 90?
So GCF is greatest common factor. It's the biggest number and variable, if possible, that fits into both terms. So 90 is way too big. It's not a factor of either term. It doesn't fit into 9 or fit into 10. So I want to think, what's the biggest number that fits into both 9 and 10 evenly? Like, what are 9 and 10 both divisible by? if anything, right?
Yeah, I mean, yes.
Okay, so just 1, right? So we don't need to write a 1. Okay. How about what else do they have in common? These two terms. Can you see the red
Yeah, I
dot
guess
that I'm? Okay. So what else do these two terms have in common?
Besides the variable p,
So p, right? They have a p in common.
yeah.
Right? So GCF, right? The greatest common factor, the biggest thing we can take out of both terms is just p. So that's what you write above it. Okay. Or you could write 1p. You don't need to write the 1 though. Okay, anytime two numbers are consecutive, they're right next to each other on the number line, they're not going to have a GCF other than 1.
Yeah.
And that's 9 and 10 are consecutive. Okay, then the next one is looking at 63p and 70. And so this one's, they definitely don't have a p in common because they both don't have it, right? 70 doesn't have it, but they have a number that fits into both of them. They have a common factor.
Mm-hmm.
Hi, man. You need to get the computer back.
That was cute. So what is that number? Sorry. Okay, someone else can, Simon, I don't want to keep doing that.
He needs the computer back.
Who can help us out here for the remainder?
Keep this.
I got you.
Okay.
So I had it the other way around.
Sure, that's fine.
So the top is going to be 9p plus 10.
Okay, so your 10, my 10 goes here.
Yeah.
Okay.
And then the other one is p plus 7.
Okay, so the 7 could come out of 63 and 70. Cool. And then who can help us out here going across?
9p.
With 9p squared. 9p. Great. Okay, so even if you had it set up the other way, it still has the same two factors. Okay, so we can write our final answer as 9p plus 10 and p plus 7. Great. Yes, there's definitely an algebraic way to do this, to write it all out. This is just a visual representation of the algebraic way. It's just called box method. And I've just found that students, this just works better. But there's definitely an algebraic way to go through it. It's the exact same thought process. It's just not as visual with literally a box. That's all. Okay, I have one more for us today and then we're done. And again, if you feel like you need some extra help on anything, you can log in today at 2 o'clock. I'll be on until 2:30. All right, I want you guys to try this one. Working through the steps for factoring. GCF, what remains? All right, we do have two numbers that make this work, 90 and -1. And there was no GCF here, so we wanted to, and we saw that it was a trinomial. It was a quadratic. Is it factorable? We did A times C and got -90, and B is 89. Are there two numbers that multiply to this that add to this? Yes. So it is in fact factorable. We do need to use the box method because A is not 1. And when we do that, our first and our last go first and last. And then we make 89m by putting in 90m and -1m, since those are the numbers that we found. Then we GCF 4 times. So going down our first column, we can only take out an m. Going down our second column, we can take out, since this is first term's positive, we take out a positive no matter what. So it's going to be +9. Going across, we can take out 10m. And going across down here, since our first term's negative, we have to take out a negative, and we can only take out a 1. So this factors into 10m minus 1, what we got here, times m plus 9. Again, you can always check your work through multiplication. Factoring is just reverse multiplication. It's going backwards. So you can always check via multiplication and see that it does work. All right, I'm gonna let you guys go. I'm sending out the email right now with your assignment in it. It's a PDF. Please submit it to Dropbox. It should be open on Blackboard right now. Office hours today and tomorrow at 2, Friday at 9 a.m. If you need any help, you have 3 opportunities to ask for it before it's due Friday at 3:15. Any questions before we peace out?
No, ma'am.
Okay. Awesome. Take care, guys.
Colin, happy birthday, brother.
Yeah, I'll stay on for just a second. I just want to ask you something.
Okay.
Thanks, brother.
Bye, Ben. Hey, I'm glad to see that you're on here. Are you doing okay?
Yeah, I had some stuff I had to do Monday. I wasn't home all day, so I had to
Okay.
take care of some stuff. I just saw your email today actually, and I just did it and sent it to you. So.
Oh, awesome. Okay, cool. And then I just don't have, I don't want to like, oh, I just got it actually. I don't want to like overload you, but I don't really have any, I don't have anything from you for this quarter. So if you look on Blackboard,
Yeah, it says 0.
Yeah, all the assignments are up. You can turn them in at any time. If you kind of just go through my YouTube playlist, each video, starting with, don't do the first video because that was a 3rd quarter grade, but starting with topic 2, 3, 4, and 5, if you just watch them, they're like most 10 minutes each, really. The assignments at the end. If you just want to do it on one sheet and then shoot me an email,
Yes, ma'am.
that would be great. And then I could get that all caught up for you.
Okay.
Okay?
Yes, ma'am. Thank you.
You're welcome. Bye-bye, Michael.
Bye.